to get started. Can you guys hear me all right with the microphone and stuff? All right, you can hear that, so it's definitely on. So, my name's Nick. That's Dan. You guys are really talkative. I love it. Social geeks, it's great. Actually, at LA RubyConf a couple weeks ago, someone said in their talks that Ruby was like a programming language for extroverts. I mean, extroverts as far as programmers go. Got kind of a laugh. So, yeah, that's the case. Anyway, yeah, I'm Nick. That's Dan. We're going to talk about pseudo real-time programming for the web. So, like when stuff happens in your app and you want a lot of people to know about it really quickly, or when stuff happens with your clients and you want your app to know about it really quickly. So the alternate title was EventMachine, Amqp, and WebSockets the musical. Someone tossed out the challenge. So our little demo app later on is going to be an interactive web-based sequencer that everyone here who has a laptop will be able to participate in controlling. So that should be fun.
If it works.
If it works. If it works. If it doesn't work, we're going to blame Flash. So just a heads up on that. So starting things right along. I'm guessing if you're sitting in this room, you know what Ajax is all about. And that is really kind of where things start when you want to communicate quickly back and forth. As we all know, Ajax, you fire off an asynchronous request, you get the response, it's nice, doesn't interrupt your pages, etc., etc., etc. We all know what's up with Ajax. And basically right now, what most of us will do if we need to keep in touch with stuff that's happening in your application is to poll your application. So just send an Ajax request, ask what's going on, server, and wait for, sometimes there will be something interesting to say, and sometimes the server will say, nope, go away, talk to me later. And that's okay, it works depending on how often you're polling, and if you've ever implemented an app with polling, you know that there's all sorts of variables to take into consideration. How often are you polling? What's the trade-off between the amount of traffic that you're generating with your polling based on the number of people that you're expecting? It all multiplies pretty quickly. And, all those times where the server has nothing new to say, it's just kind of wasted time on everyone's part. And on the other hand, too, you poll too frequently, or if you try to reduce the amount of wasted requests and poll less frequently, you might be missing out on some kind of information that you would like to have delivered a little more quickly. So, polling, we all pretty much get that. Another way to do polling, kind of a successor to that, is Comet, or long polling. And really just the same as Ajax. It has a small twist in that you make your request and the server just holds that connection open. If there's nothing for it to tell the client, it just says, okay, hold on, wait until I have something to tell you. And when it does have something to tell the client, it sends the body of that HTTP request back to the client, and the connection closes as usual with an Ajax request. Only then the client will then turn right around and immediately reopen a new connection and just kind of wait for data. So if you've ever wondered kind of what the Comet is all about, what long polling is all about, that's essentially what's going on there. And turns out this is actually a really good way to do this kind of stuff with the web, because you solve a lot of your problems with, you're not having all these redundant requests. If your server is able to handle all these simultaneous, open connections, and servers have gotten pretty good at doing this. Nginx in particular has a really nice long polling mod if you need to do this kind of stuff. It's great because you get the data as soon as it comes down the pipeline, and it really takes some of the guesswork out of polling intervals and all that kind of stuff. And honestly, if you walk out of here today and just go add some long polling to your application, then you'll be a step ahead. So, but we've got some cooler stuff that we can talk about, and that's the various push technologies. So, push is something we've heard about. I seem to recall 6, 7, 8 years ago, Microsoft talking about push, and it was a total flop. And lo and behold, there's platform-specific stuff. And to be honest, I didn't even really know there was platform-specific stuff until Dan made this slide earlier tonight. So apparently Mozilla and Opera all have kind of their own platform specific implementations of push stuff. But who really knows about it? Who uses it? I certainly didn't. Oh man, I meant to revise that slide, but I guess Google barfed on me. So yeah, I mean, WebSockets is really the next way to go for this push stuff. And you guys probably heard of WebSockets because you read the email saying we're talking about WebSockets tonight. But also HTML5 is a big hype kind of right now. WebSockets is part of the HTML5 spec. This is something that's gaining a lot of momentum, a lot of traction. WebSockets is really, you know, it's easy to implement in a lot of ways. It is getting a lot of traction. And yeah, so we even see it in a handful of browsers starting to show up in the JavaScript APIs, and that's what we're going to demo tonight. So I think I'll turn things over to Dan to talk some more specifics about what's going on with WebSockets.
Okay, so who here has used WebSockets? Anyone? Jordan, I know you have. We've worked on them. Okay, so it works just like an HTTP request at first, but then after the request is made, it's like a full duplex socket connection. So you can send data down to the client can send data back up to the server. It's all good. So on this slide here, I'm showing, you know, what you do to send a WebSocket request to the server. The only differences is that you have a connection header, which says upgrade, so that your proxy can determine what to do with it. So if you're not going to send it to your app server, you're going to send it to your WebSocket server. And then the upgrade is WebSocket. So I don't really know why they need that, except for they may have other type of upgrades in the future. And then the server just has to respond with those 4 headers that you see there, which is the connection upgrade, upgrade WebSocket, and WebSocket location and origin. And once that's been done, once the request is and response handshake has happened, then you just have a full duplex socket connection. If you want to send data down to the client, it's a very, very simple process. It's a UTF-8 byte array, and the first 2 bytes are just 00, and the last 2 are FF. That's it. That's all you got to do. You just wrap it in those, send it down, and it will work. And then on the client side, this is as simple as it gets, I think. You create a WebSocket object in JavaScript, and then there's various different event handlers. One for when it opens, when the connection has been established, one for when a message comes down from the server, and one when the connection has been closed for whatever reason. Maybe the server crashed or something like that. And then to send it, it's simply, you know, socket.send, and you can send any kind of data there. It's probably best to be JSON or something like that. And the benefit of doing all this is that you don't have to do that long point concept, and you don't have to really wait or reestablish a connection after data's been sent. It just gets pushed out, and you can push it out pretty dang fast too, as we'll hopefully see here in a few seconds. Okay, so now kind of tangential, very tangential actually, going from WebSockets to a very, very brief overview of AMQP. Is anybody familiar with AMQP? Okay, so people are more familiar with AMQP. The reason we're going over this is because we're using it to do our demo. So this is a very, very, very brief overview of what it is, because it is it's an advanced protocol, right? It's basically pub/sub, platform agnostic. The protocol itself is binary. The core concepts, which for those who haven't used AMQP, what you should know about is there's a queue. The queue is essentially where the messages get stored. That's what you care about, right? The messages on a broker like this. An exchange is something that categorizes messages. You can have different exchanges that are used for passing different kinds of information around. There's 3 different types of exchanges. There's a topic exchange, which sends, when someone publishes a message to a topic exchange, it basically sends it out to all the people who care about that particular exchange. And you can get kind of advanced with the routing of it based on routing keys. There's a direct exchange. You just want to publish directly to a queue. You just want to say, I want to send it to this queue. Maybe the queue is for an email address. You just want to send an email directly to that particular queue. And then there's fan out, which is like topic in the sense that it sends out to end clients. But instead of having advanced routing techniques, it's just simple. It's kind of dumb. It just shoots it out, one to end. Then there's a binding. A binding is what links queues and exchanges together. So if you have a queue and you care about exchange cars and exchange stocks, then you bind your queue to those particular exchanges, and you'll get all the messages that are published to those exchanges into your queue so that you can act on that data. And then the broker, which is basically the server, and there's plenty of server implementations. RabbitMQ is one of the ones that's pretty popular. There's Cupid, there's ZeroMQ. There's quite a few of them. So that's kind of what AMQP is. It's a way of getting messages around between your servers, essentially, or your peers. Wow.
You guys might just want to read this slide on the internet later.
Yeah, I'll just. This is just an example, since this is a Ruby thing, and I don't think we've had any Ruby in our presentation yet. So here's a little bit of Ruby of how you would do something with AMQP in a Ruby script, and it's very simple. In these few lines of code, what's happening is we're creating a new queue, which is happening down on line 5 or so. It says mq.queue1. What that does is it's connecting to the broker, telling the broker that it wants to declare or set up a queue named Q1 so that we can later put messages in it or pull messages out of it. And then what it's doing after that is it's binding that queue to a topic exchange called topic. And there's a syntax there, clearly, right after that. But you guys get the gist. There should be a dot there. And what that's saying is, so whenever a message is published to that topic and routed to my queue, let's put this message out, whatever it is. Let's just print it out. And then a few lines up above is how we would publish to a particular. And again, there's some weird, I don't know what happened here with the formatting, but I think you guys get the gist of it. We're setting up a periodic table with EventMachine, which basically says every second, call this block. And that block has mq.topic, topic, publish, ping. So the overall result of this code is that even though it's totally pointless, you output a message every second, ping. And that's pretty much what's happening. So use AMQP, you just play with it. Just goof off of it. It's pretty fun. Okay.
Yeah. So whoever has their laptops here, feel free to hop on our little wireless network, pull up that IP.
It's called
the SRB is the wireless network. Yeah.
Yeah, we're probably doing this illegally. I hope no one minds.
So yeah, one reason we mentioned AMQP, like Dan said, we're using it in this application, and in some ways, we're actually just using WebSockets, the WebSocket API, like an AMQP client, in essence.
It is, yeah.
So about a year ago, we did, Dan and I worked on a site together that used AMQP to deliver messages between a lot of clients really rapidly. And we had to kind of hack that, the client connection type stuff using Flash and JavaScript bridge type stuff, whereas WebSockets kind of fills that role really nicely now. So. Oh yeah, let me check. I am on the SRB network. Oh.
So everyone that has this stuff, get this URL ready. I don't know if it's running right now. A few people would be kind of cool, but.
Well, I am on. I might as well fire this up.
All right, so you want to explain the...
Right, yeah. So what we've built here is an interactive sequencer. And if you guys are musicians, you know a sequencer is you just kind of run through a loop and you say you've got some samples.
Okay, good.
And you tell which beats you want the sequencer to play each sample on. So this little guy here is a Monome. It's a fun little musical toy. It's just a grid of buttons that I can plug in and query over USB. And what I've done is written a client for this guy that is, you know, I'm modeling the grid and what's going on with the sequencer and all that stuff. It's also an AMQP client that is talking to an AMQP server on Dan's laptop here and sending messages to it. For example, like it's keeping track of the metronome and the time, and it's sending all these play messages as AMQP messages to a server. Now, Dan has written a little client for that AMQP server as well, to which he's subscribing to these messages, these play messages. And he is then delivering them with WebSockets to the web browser, which is then playing these sounds in his web browser. And hopefully, if you guys can get on, you'll be able to hear something similar in your browser. Because when the clients then click and toggle these buttons, they're sending messages via WebSockets back to the AMQP server, and it's just messages flying all over the place. So has anyone actually managed to get on this URL yet? Nobody? Everyone's shaking their head.
I was earlier.
It says connected. And if you click on something, do you see it? Oh, connecting.
Thank you. Let's get some
Let's pull some logs up here.
We need to reboot the server.
As we all know, this is a live demo, so it is bound to not work somehow.
There's people connecting.
I see it.
Anyone see that?
Oh, someone just turned a button on here.
Who did that?
Who did that?
All right.
Go, Brian. Okay, yeah. So
yeah, try to reconnect and.
you can turn your speakers up too. So.
All right, don't get too crazy.
So if you are actually interested in the musical aspects of the first 5 are samples. We've got a hi-hat, a weird annoying thing, 2 snares, and then a kind of a bass. So.
And there's probably going to be some latency, so it'll sound like an echo.
We can't keep pressing buttons on there.
Yeah. So if we press buttons on here, it will affect your browser as well. You guys said you wanted.
I'm seeing some laughter here, so yeah. Exactly. I don't remember who said it on the mailing list, but we took the challenge to make this musical very seriously.
Was that you? Dang you.
Very clever, guys. Nicely done.
So how many people have this working on their computer? Jordan does. You do. The sounds may be totally out of sync, but how quick is when I'm clicking on it, showing up?
Pretty easy.
Pretty quick?
I think Flash, right? That's the delay.
Well, this is all JavaScript here. The Flash is what's playing the sounds because
Flash is playing the sound, so we occasionally get some like system latency just playing the MP3.
So here, let's try this.
Oh, it's each sound in MP3?
Yeah.
Yeah.
For MP3?
Yeah. So here, I'm turning some stuff off here, right?
So those bottom 3 don't matter. So if we go a little more slowly. Jordan, what is wrong with your computer?
Your computer's old. It's black. It should be like silver like ours, right? But, I mean, if it's working fairly seamlessly, I don't know how. I think this would be a lot less quick with Ajax or long polling. So
yeah, probably not possible at all with polling.
I don't even know.
So yeah, that is our interactive sequencer.
The actual WebSocket here is being over by Flash.
No, the WebSocket is
the
the
real
JavaScript.
WebSocket,
Yeah.
The only reason we're using Flash is because the audio tag is not very good.
So
Actually, it's really good in sync here because we're wired up.
yeah. I guess we could do some Q&A. Patrick's got the mic back there, so if anyone has questions, raise your hand, make yourself known. In the meantime, I'm going to turn my speakers off, and you guys can feel free to play with the lights on that. Fun little visualization tool. All right, question.
Is it on?
Hey.
Does it open WebSockets at once, or is it just like one that gets messages sent one at a time?
It's just one WebSocket connection. Each sound that's played is a message being sent down from the code that's controlling this. Can you guys hear me, by the way? Yeah. All right, good. So yeah, it's just every packet or message payload. If you open up, someone opens up console. Here, I'll show you guys. The console has some output statements, so you kind of see what's going on here.
Alt-Command-J in.
So you can see right now, these are all the messages coming down to my browser and to all your guys' browsers. Each one is a little JSON packet, which isn't efficient, but it was efficient for us to get this thing working in the amount of time we did so.
But the question as far as the number of connections, each client has one socket connection open to the server, and it stays open. It persists. I mean, you think about it just like a socket connection. So. I have a timer running on my laptop that's sending out all these messages. So, in fact, you could even pull up. Yes, there you go, code.
But it's an EventMachine channel, right?
Essentially, yeah.
EventMachine is,
is
doing a lot of the heavy lifting. EventMachine really is the unsung hero in actually all of this, because Dan's WebSocket server is built on top of EventMachine. Our AMQP client that we're using is built on top of EventMachine. My metronome for the sequencer is using EventMachine. And we really need to have someone give an EventMachine talk here sometime, because it's pretty much like the best Ruby code out there. So.
Yeah. Well, I think it's more C than Ruby, but it's good.
I have another question. So you're having Flash just grab the MP3 files, and then you're just signaling play this one, play this one, play this one?
Yep. Yeah. Actually, there's a preload command that this thing sends out that says preload these MP3s, gives them a path, essentially a URL. And then the Flash client then preloads those and gets ready to play them. And it has a unique identifier, which you can see. They're just strings that are actually really numbers, but string representations of numbers. And those are the identifiers. Ha, who did that?
Everyone did it. We'll never know. So, anyone else questions? Microphone? Pass it around. I should make my SDRuby sailboat again. I challenge you guys to make an SDRuby sailboat out of the LEDs. I did it on Flickr already.
So you said you used EventMachine to provide the WebSocket server. How was the implementation? I mean, would you base it off of the existing HTTP stuff, or have to do it raw?
I started from scratch. So when I heard about WebSockets and being in Chrome, I thought it would be fun to create a WebSocket server. So I created WebSocket server, which you can find on GitHub. And it's simple. Basically, I just extend the connection class and deal with the handshaking, and then that's it. That's all you got to do. It's really just a socket connection that has HTTP headers. That's it.
Yeah, that's one nice thing about WebSockets. It's super easy to implement. And it looks a lot like an HTTP request, so it's going to go right through firewalls. And yeah, it's good stuff. Everyone is way too absorbed into making pictures on this thing. It's like, usually we have really great questions. Thanks, we love being here too. So. Oh gosh.
Just abstract it a little bit. There.
Yeah. This is like going to ruin our talks for the rest of the night, because everyone's just going to be like clicking on this thing.
If we had, we should just have a lot more pixels, then you guys have a lot more fun, right? You can
do it, change it, refresh.
We could. Yeah.
We could. Whatever.
Any questions? Good.
I guess we explained it too well, Dan.
Or not. Yeah.
Or not well enough at all. So, all right. Well, hey, thanks, guys.